In this video, I will talk about the centrifugal acceleration and acceleration due to gravity. So let's consider this is the Earth, which spins about its axis with an angular speed of omega. And we have a point here P that makes a latitude theta. So this is my x-axis and this is my y-axis, which is passing through the center of the Earth. And this point P moves into a circle, and the radius of this circle, it can be given by r cosine theta. If you look at this trigonometry, you can simply find it out. And as this point is moving into a circle, there would be a centrifugal force. And the centrifugal force is given by this equation, m omega squared r. And r at this point would be r cosine theta. So that is the centrifugal force. So what does this mean? That means the centrifugal force is latitude dependent. It is maximum at the equator and minimum at the pole, or zero at the pole. And because it is maximum at the pole, the acceleration due to gravity has more changes due to the spinning of the Earth at the equator and no effect at all at the pole. Okay, and also because there is more centrifugal force, the Earth radius is slightly bulged out this way. I'm exaggerating a fact here, like just like this. So if I have to draw it, so Earth radius would look like this. Why I have drawn this way? So because there's more centrifugal force at this point, the Earth radius at the equator will bulge out, and there will be no change at all on the pole at all. And in fact, if you have any spinning object, the radius of the equator will be slightly bulged out and the pole will be slightly smaller compared to the equator. All right, so and what's the value of the centrifugal force? This is the value. So if I compare the centrifugal force and the weight, or the centrifugal force and the acceleration due to gravity, let's take out, in fact, what I'm trying to say is, let's take out the ratio of centrifugal. So here the ratio I'm considering is this ratio here, centrifugal acceleration and the acceleration due to gravity. So we have centrifugal force. So the centrifugal acceleration would be simply force divided by the mass. That will be centrifugal acceleration. So that is my centrifugal acceleration, and this is the value of g, which is acceleration due to gravity. Now let's plug in all the values. The angular speed of the Earth is given by this number here. R is the average radius of the Earth, which is given by this equation, and I am considering at an angle theta here. So theta equals to 45. This would be the value, and that is 9.81. And if I plug in this value, the ratio would be 2.4 times 10 to the negative 9. So what does this mean? That means compared to the acceleration due to the gravity, the centrifugal acceleration is very, very tiny, insignificant. Okay, so the spinning of the Earth does not make that much difference in to the value of acceleration due to gravity. And for those who are interested in knowing how do I get this value of angular speed of the Earth, here is the equation. Omega equals to 2 pi over t, and t is the time period. What does the time period means? The time period means that how long does it take for the Earth to complete one complete cycle, which is 24 hours. So converting it to second, if you plug in, that's the value I get. And this is the average radius of the Earth. So this is it from this video. So in summary, centrifugal acceleration is very, very insignificant compared to the acceleration due to the gravity. Thank you very much. And do not forget to like, share, and subscribe the channel. Thank you so much.